Good morning. We're back at Mech 2320, that is Motors, at Chattanooga State in Chattanooga, Tennessee. Welcome. Okay, yesterday we had a brief review of Ohm's Law. Today we want to look at a little bit more of Ohm's Law, but we want to include Kirchoff's Law with that. So let's start again. We all know what this is, right? A simple battery, okay, or a power supply, whichever you like to call it. Short plate is negative, long plate is positive. Electrons travel from the negative side to the positive side if you have a conductor in place. So let's put a conductor in place. All right, we have a complete circuit. We have a power source, or a source of electrons, or a power supply, or a battery, whatever you like to call it. And we now have a path by which electrons can flow from the negative side all the way around the circuit to the positive side, so we have a circuit. Okay, the problem with this circuit is that it has nothing to limit the current flow, assuming that this is pure copper wire and a high grade of copper. So we want to put a resistor or some resistance in the path of current flows so that we can lower the number of amperes that we have flowing. But we're gonna, since we're talking about Kirchoff's law, I'm going to put two resistors in the circuit. We'll have resistor 1 and resistor 2. Let me make my 1 a little bit better than that. Okay. And now then, we have something that resembles a simple circuit. It is a series circuit, and the reason it's called series is that we have resistances connected in the same wire. They are in series with each other, so we call this circuit a series circuit. Current is flowing. In this direction. Now, yesterday we talked about voltage drops, okay, and what we say is, we say that for the power supply, electrons are pushed out of the negative pole around the circuit and back to the positive pole. And since the resistors are opposing that current flow, we say that the polarity of the voltage drop, and let me slow down here just a little bit. I've got current flowing in this direction, and we say that the polarity of the voltage drop will be negative at the end of the resistor at which current enters. Okay, so what we're going to have is, over the total resistance, we will have a negative polarity here and a positive polarity here. Okay, because the voltage drop across that collection of resistors opposes the current flow. Now then, if I were to take a voltmeter and I were to set it on a voltage scale and put the leads across each resistor, I would read the voltage drop across each resistor. So what I would find is I've got a voltage drop here, and I've got a voltage drop here, and we'll call this one the voltage drop across resistor 1, and this one is voltage drop across resistor 2. Okay, and what we would find, and this, by the way, is my voltage source, and let me put, I'll put voltage source right here. We would find that the voltage source would be equal to the sum of the voltage drops. And this is Kirchoff's law. Okay. If I were to increase my number of resistors over here, you would find that, no matter how many resistors I had, the sum of each voltage drop, the sum, adding them all up, would be equal to the voltage source. Okay, this is an important law for you to remember when you're doing your troubleshooting, no matter what the circuit is. As I have said before, it applies to DC circuits and to AC circuits. Now then, since it's a series circuit, the current flowing in R1 is identical to the current flowing in R2. It has nowhere else to go. The current can only go through those two resistors the way we have done this. So we can tie Ohm's law into this, and we can make a few more statements about the behavior of this circuit, and we can say that the voltage source, and by the way, that's the voltage applied, right? The same thing. The voltage source would be equal to the current times the value of resistor 1 plus the current times the value of resistor 2, right? You recognize Ohm's law, right? V is equal to I times R. Okay, the current will be the same in both of these. Okay, so you just take that current, multiply times the Ohm's value of R1, and that will give you VR1. And this one will give you the value of VR2. So, Kirchoff's law. Okay, this probably looks familiar to a lot of you. If it's the if it's the first time you've seen this, a little work, not a lot, will bring an understanding of Kirchoff's law. And as I said before, it is one valuable tool for troubleshooting.